Yeah. All right, students. So once again, good morning to one and all. So we'll start off. Yeah. So last class வந்து நம்ம electric fields and charges வந்து நம்ம start பண்ணியிருந்தோம். We started with that chapter. So today, we'll have a quick recap because there's been a gap also. நடுவுல ஒரு gap இருந்துச்சு. So அதனால ஒரு recap பண்ணிட்டு நம்ம we'll continue with the concepts. Electric field இருக்கட்டும், electric charges இருக்கட்டும், Coulomb's force of attraction இருக்கட்டும். So we'll have a quick recap. அதுக்கப்புறம் we'll continue with the lectures. சரிங்களா? So நான் என்னோட ஸ்க்ரீன் வந்து ஷேர் பண்றேன். Today, I'm using the animation tool. So that we can visualize. So யார் மிஸ் பண்ணியிருந்தீங்களோ so it will be very useful for everybody. So எல்லாத்துக்குமே இந்த செஷன் வந்து will be a recap. So let me share the screen. ஸ்க்ரீன்ல வந்து ஆடியோ கூட ஷேர் ஆகுதான்னு ஒரு வாட்டி செக் பண்ணிக்கோங்க. ஏன்னா சம்டைம்ஸ் ஆடியோ வந்து ஷேர் ஆகாம இருக்கலாம். ஸோ அதனால யூ ஜஸ்ட் செக். ஸோ இப்போ I've just started screen sharing. ஆடியோ ஆல்சோ நான் வந்து ஷேர் பண்ண போறேன். சரி, ஐ ஹோப் ஸ்க்ரீன் உங்களால பார்க்க முடியுதுன்னு நம்புறேன்.
Yes, sir.
Okay. Okay. So starting off with electric charges. So நம்ம charges வந்து நம்ம how can we basically create the charges? What are the methods to induce charges? We'll look at that. So அங்கிருந்து நம்ம start பண்ணி we'll look at all the aspects. சரிங்களா? So I'm just going to play the animation, first one. So let me know if it is audible. Audible இருக்கான்னு first பார்த்துக்கோங்க. That is very important.
Methods of electrification.
ஆடிபிளுங்களா எல்லாத்துக்குமே மெத்தட்ஸ்
Yes,
ஆஃப்
sir.
எலக்ட்ரிஃபிகேஷன் அப்படிங்கிற அந்த ஆடியோ வந்து கேட்டுச்சா? ஐ ஹோப் எவ்ரிபடி இஸ் ஏபிள் டு ஹியர். ஓகே.
Some strange things seem to be happening on Rita's birthday. The balloons seem to be pulling her hair. The thermocol balls started moving towards the comb.
ஸோ இங்க பாத்தீங்கன்னா we are having two different situations. The first one is hair moving towards the balloon. ரெண்டாவது பாத்தீங்கன்னா comb நம்ம வந்து comb பண்ண பிற்பாடு when you take it towards small bits of paper இல்லாட்டி tiny thermocol balls கிட்ட நம்ம கொண்டு போனோம் அப்படின்னா what is observed? You can see that they get attracted. So what is this? What is the concept behind this? Anybody?
Static electricity.
Yes, very good. So it is static electricity. இது electrostatics அப்படின்னு சொல்றோம். So basically distribution of charges. So when they are present at a point, at a fixed point, we are trying to study them. So இங்க வந்து when the charges are equal and opposite, you know that unlike charges attract each other and like charges repel each other. So based on that concept, we are trying to understand the orientation of charges. So what is electric charge? How can you induce electric charges? By friction and by conduction, by convection, all those things we are going to see. So the different methods. Seringla? So we'll continue.
Is this some supernatural force or pure physical phenomenon? Let's find out. When Rita combed her dry hair, both the comb and her hair became electrically charged due to rubbing. The hair attracted the balloon, and the comb attracted the thermocol balls. Such localized charges are called static charges, and the electricity produced by them is called static electricity.
So these charges we call them as, due to friction you're trying to create the charges. So they are called static charges, and the electricity produced due to them, அதை வந்து நம்ம static electricity அப்படின்னு சொல்றோம். Simple. So like this you can define the static electric charges. சரிங்களா? We are going to the next module.
Let's perform a small experiment. First, let's rub this glass rod with a silk cloth. When we rub the glee charged, on the other hand, the cloth gains electrons and becomes negatively charged.
Okay, புரியுதுங்களா? So how there is an inducing of charges, how glass rod became positively charged,
Yes, sir.
how the cloth became negatively charged. The phenomenon here is இங்க இருக்கக்கூடிய கான்செப்ட் பாத்தீங்கன்னா any object that loses electrons, what do they form? Don't you think it forms a cation? Example, group 1 elements எடுத்துக்கிறீங்கன்னா group 2, group 3, all these metals, right from alkali metals to rare earth metals to the aluminium group or the aluminium family, the tendency when they each and every element in these groups would like to donate electrons. So when they donate electrons, what is the charge that they get? They get a positive charge, isn't it? அதே கான்செப்ட் தான் இங்கேயும். When you're going to rub the glass rod against the silk cloth, the electrons are lost from the rod. அதனால rod ஒரு charge வந்து will be positive because it is losing electrons. And who is gaining electrons here? The cloth is gaining electrons. Clear? So any object that gains electrons are negatively charged. It will form anion. For example, chlorine எடுத்துக்கலாம் நீங்க, fluorine, chlorine, group 17 elements இல்லையா? All of them want one electron to satisfy the octet. So they gain electrons and become negatively charged, isn't it? So the same logic here applies here also. So the glass rod loses electrons, becomes positively charged. The silk cloth will gain electrons and become negatively charged. This is the basic concept that you should know. சரிங்களா? இதுல ஏதாவது டவுட் இருந்தா கேளுங்க. I hope this is clear. This is very important. Yes? Is it clear to all of you?
Yes, sir.
Yes.
Yes.
Okay. சரி, continue பண்ணலாம்.
Let us now touch these pith balls with the glass rod and see what happens. Okay. The ball.
Pith balls அப்படிங்கிறது என்னன்னு பாத்தீங்க அப்படின்னா they are nothing but metallic balls. The balls which are made up of metal, the conductors, so they are very good conductors of charges. சரிங்களா? So when you took the glass rod and when you touched them, what happened in this case? என்ன நடந்துச்சு? There was a transfer of charges. From where to where? Charges were transferred from the glass rod to the pith balls. இல்லையா? So there was a transfer of charge which was taking place. And now the pith balls have moved apart. எதனால they have moved apart? அது முன்னாடி இந்த மாதிரி அட்டாச்சாவே இருந்திருக்கலாமே. Why did it go apart? Anybody? What is the reason behind this? எதனால the pith balls moved apart? We obviously know there was a transfer of charge. என்ன charge? Positive charge transfer ஆச்சு from the glass rod to the pith balls. அது நமக்கு புரிஞ்சுது. ஆனா இந்த சேர்ந்து இருந்த இந்த pith balls வந்து எதனால it is going apart? What is the reason behind it? Anybody? Let me see how many of you are thinking. Yes? இப்போதான் நான் explain பண்ணேன். Who can correlate the phenomenon? Yeah. Quite simple. Conduction இல்ல. It is something to do with nature of charges. I'm giving you a clue.
Like charges repel each other.
Very good. Like charges repel each other. ரெண்டு pith ballsக்குமே positive charges தான் நம்ம transfer பண்ணிருக்கோம். ரெண்டு positive charged spheres பாத்தீங்கன்னா will not get attracted. They will get repelled. Repelledனா they will move apart from each other, isn't it? So by properties of charges, like charges would repel each other and hence the pith balls move apart from each other. So that is the concept that we learn. Is it clear? So this is what is observed here. Okay, so moving on.
Repel each other. It seems both these balls acquired the same type of charge from the glass rod, and that's why they are repelling each other. That means like charges repel. Now, let's take another pair of pith balls. We will touch one pith ball with the glass rod and the other with the silk cloth. Well, attract each other this time. Why?
Why do the balls attract now? What is the concept again?
Unlike charges attract.
Very good. Unlike charges will attract each other. So both of them have opposite charges. One of the pith balls have positive charge, wherein the other had negative charge. So positive charge engirandu vandhudu? The positive charge was transferred by the glass rod, wherein negative charge was transferred by the silk cloth, and hence they got opposite charges. They are attracted to each other. So that is the concept here. Okay, so now moving on to the next part.
Now, it seems the pith balls acquire different types of charges, and that's why they are attracting each other. That means, unlike charges attract. We have a glass rod here, but is it charged or uncharged? How do we find that out? For that, we need a gold leaf electroscope. It's a simple instrument used to detect the presence of electric charge body.
Okay. So now, இப்போ வந்து we are going a step higher. இப்போ வந்து we try to find out or identify the nature of charge on an object. So to identify the nature of charges, obviously we cannot see the charges with our naked eye. So therefore, we use an instrument called a gold leaf electroscope instrument. It is also called a bell jar experiment. So very, very similar. So இங்க வந்து நம்ம gold leaf experiment, gold leaf electroscope அப்படின்னு சொல்றோம். So the gold leaf electroscope consists of, you can see there is a wooden cork, the one hole wooden cork through which there is a metallic conductor. At the end of the metallic conductor or the copper wire, you can see there is a gold leaf. கீழே வந்து ஒரு gold leaf வச்சிருக்காங்க. ரெண்டு gold leaves இருக்கும். It is a pair of gold leaves that are present. சரிங்களா? So these gold leaves are very, very thin. And when they acquire charges, they will either touch each other or they will go apart from each other. சரிங்களா? So that is what we understand. On the top, you can see there is a metallic disc where you can touch the metallic disc using different conductors or different charges and try to identify. So this is the experimental setup of a gold leaf electroscope. So we will see how it works. So that is what we are going to learn.
It consists of a copper rod connected to two thin gold leaves at the bottom end and a metal disc at the other end. The gold leaves are enclosed in a transparent container. When we touch a charged object to the metal disc, the charge from the object moves to the disc. The charge flows through the copper rod to the pair of parallel strips of thin, flexible gold leaves. On acquiring like charges, the gold leaves repel each other and therefore diverge. But if we touch the disc with an uncharged object, the gold leaves of the electroscope will show no deflection. The deflection of the gold leaves, therefore, indicates the presence of charge on a body.
So when the gold leaves are going to deflect, therefore, what does it mean? It means that there is a charged object. The object is having some charge. So that is the meaning. So this is how you can detect the charges using a gold leaf electroscope. Charge இருக்கா இல்லையா அப்படிங்கிற ஒரு basic detection தான் இது இந்த இன்ஸ்ட்ருமெண்டால செய்ய முடியும். So that is what we are able to understand from this. சரிங்களா? Is it clear? The gold leaf electroscope. Shall we go to the next module?
Yes, sir.
Okay.
The process of charging a body is called electrification. Electrification or charging can be done in three ways: charging by friction, charging by conduction, and charging by induction. Click on each method to learn more.
So charging la vandu we have three different methods. One is charging by friction, which we already learned now. By using a glass rod and a silk cloth, நம்ம ரெண்டுத்துமே when we rubbed against each other, by friction, we are able to charge the rod as well as the silk cloth. சரிங்களா? So that is friction, charging by friction. Now we are going to go to the next two modules. So ஒன்னொன்னா பார்க்கலாம், charging by conduction and then followed by charging by induction. So first we will see conduction method.
When a charged body comes in contact with an uncharged conductor, charges flow from the charged body to the uncharged conductor, and the uncharged conductor gets charged. This method of charging is called charging by conduction.
Okay. So இங்க என்ன பண்றோம் நம்ம? If you are bringing a charged conductor next to a uncharged conductor and you are trying to touch it. So when you are touching, you are trying to transfer the charges from one of them to the other. So that is basically charging by conduction. So conduction is basically mere touching and you are basically transferring the charges. So அதை வந்து நம்ம charging by conduction அப்படின்னு சொல்றோம். ஓகேங்களா? So how can we do this? You can take a pith ball which is uncharged. You take a glass rod. நம்ம glass rod வந்து எப்படி charge பண்றது நம்ம கத்துக்கிட்டோம் charging by frictionல. So அதை charge பண்ணி நம்ம அதை கொண்டு வந்து when you touch it, next a pith ball which is uncharged, what happens? You are trying to charge it by the method of conduction. சரிங்களா? So this is called charging by conduction. Is it clear? By touching it, you are able to transfer the charges. சரிங்களா? So you are not rubbing it against the ball. You are just touching it and doing the transfer. So we now move on to the next part, charging by induction method.
Observe this uncharged metal sphere placed on an insulating stand. An uncharged metal has equal number of positive and negative charges evenly distributed throughout its surface. Now, we bring a positively charged glass rod close to the sphere. The rod attracts the negative charges on the sphere, and the negative charges get accumulated on the surface near to the glass rod. At the same time, the positive charges on the sphere get repelled and move towards the rear end of the sphere. Let's now touch the rear end of the sphere momentarily. This will earthen the rear end. So, all the positive charges at the rear end leave the sphere through the hand, and only the negative charges remain at the end close to the glass rod. If we remove the rod, the excess negative charges on the sphere spread evenly on the entire surface, and the sphere becomes negatively charged. This method of charging is called charging by induction. In this method, the charged body does not lose any charge to the conductor.
So in this method, இங்க நம்ம என்ன learn பண்ணோம் அப்படின்னா in this module, so we have learned the third way of charging, the third mode of electrification. So charging by induction அப்படின்னு சொல்லணும். Induction அப்படின்னா you are not touching the object. Without touching the object, you are trying to charge the object. சரியா? So without touching, if you're able to charge, you call that as charging by induction. So that is the name given to it. Okay. So இதை வந்து நம்ம how do we do this? You take initially you take an uncharged sphere. So ஒரு uncharged pith ball or uncharged metallic sphere அப்படின்னு சொன்னோம்னா they are having charges but equal and opposite charges. So equal and opposite charges na total charge வந்து எப்பவுமே 0-ஆ தான் இருக்கும் இல்லையா? So when I have plus 5 coulombs, 5 coulombs in a conductor, now what is the overall charge in that conductor? Plus 5 and minus 5 will cancel. Obviously நம்ம 0 தான் சொல்லுவோம். So எந்த ஒரு ஆப்ஜெக்ட் நம்ம uncharged அப்படின்னு சொன்னா கூட அதுல charges இருக்கு. Evenly they are distributed and equal and opposite charges. அதுதான் meaning. Okay, because due to conservation of charges, because charges are conserved. So because of that, we always say whenever you talk about uncharged object, that means they contain charges equal and opposite in nature. That is why they are uncharged. That is the meaning. So இப்போ நம்ம வந்து we take a glass rod next to an uncharged metallic sphere. நமக்கு தெரியும் uncharged metallic sphereல distribution of charges வந்து are equal and opposite. So when you take a glass rod close to it, a charged glass rod having positive charges, you don't touch it, you are going to place it at a certain distance. So அப்படி நம்ம வைக்கும்போது what is going to happen? The charges in the metallic sphere, the negative charges and the positive charges, they accumulate at the rear ends. So positive charge is going to attract negative charge. Therefore, negative charge will move towards the end where the glass rod has been placed close by, and the positive charges will move to the other end. Seringla? And when you touch the other end with your hand, what is happening? You are trying to provide the earthing, and all the positive charges will disappear. They are moving towards you. So the metallic sphere is going to be negatively charged at the end of the day. So we are trying to charge it negatively. So this is by the method of induction. இதுதான் நம்ம induction method அப்படின்னு சொல்றோம். Okay. So now we'll move on. So these are the three different methods of charging.
Let's recapitulate what you have just learned in this animation.
So இது வந்து ஒரு total summary of what we have learned. So what is meant by static electricity and how objects are positively and negatively charged? Properties of charges நம்ம பார்த்தோம். Like charges will repel, like charges attract. And for detection of charges, what is the instrument we used? We used a gold leaf electroscope, isn't it? So, and then we learned about conductors, insulators. Conductors அப்படிங்கிறது வந்து materials which allow the charges to pass through them, and materials which don't allow charges, you call them as insulators. For example, plastics, glass, all these are insulators. Most of the metallic objects are conductors. And process of charging வந்து நம்ம அதை electrification அப்படின்னு சொல்லுவோம். And the different modes or methods of electrification வந்து we learned 3 different modes today: friction, conduction, and induction. Okay, so these are the different aspects of this today's module. So we'll move on to the next one. So we'll try to visualize an electric charge now using a 3D animation.
Electric charge. When you walk across a carpet and reach the doorknob, you get a static shock. It is due to transfer of charges from carpet to your body caused by friction. Charge is a property of matter by which it gets attracted or repulsed by other charged bodies. Atoms have equal number of positively charged protons and negatively charged electrons, making the atom electrically neutral. The charge on electron is the smallest integral value of charge in nature. The concept of charge is due to gaining or losing of electrons by an atom. If it loses electrons, it becomes positively charged. And if an atom gains electrons, it becomes negatively charged. Matter can be electrically charged by friction, induction, or conduction. Take a balloon and rub it with a silk cloth. Some electrons from the silk cloth move to the surface of the balloon, thereby making it negatively charged. This is the process of producing a charged body by friction. When such balloon is taken near a neutral object, such as pieces of paper, they get attracted to the balloon. This is due to induction phenomenon. In induction, when a charged body is brought near an uncharged body, the uncharged body acquires charge temporarily. In conduction, however, an uncharged body gets charged due to the sharing of charge between the charged and the uncharged bodies when in contact with each other. Summary. Charge is a property of matter by which it gets attracted or repulsed by other charged bodies. Charges are produced by friction, conduction, or induction.
Okay, so Nama, we have learned now the different methods of charges. So this was a quick recap of what we learned. So now moving on. So electric charges. The electric charges, we are looking at how they are positively charged species. You can see the electric lines of forces are moving apart from each other. So this is how we represent them. But for negative charges, you can see they are moving towards them. Electric field lines would move towards them. Okay, so this is how we represent it. Moving on to the next one. So here, activity. So by friction, so which are the objects which can be charged by friction? You need to drop it in the appropriate columns.
Glass rod, metal rod.
Silk cloth.
Metal rod, glass rod, or silk cloth. Okay. So by friction, you can do it.
Try again.
So you have to pull it actually and drop it here.
Try again.
Silk cloth, somebody said.
Excellent.
Yeah. So silk cloth, you can do it. And by conduction?
Metal sphere.
Metal spheres. Metal.
Excellent.
Okay. Metal sphere can be done. Okay.
Metal.
And by induction?
Paper pieces.
Balloons.
Excellent.
Okay. So in the Mari, you can basically bring in the objects and just trying to understand by friction, by conduction, and by induction how you can charge the objects. Cherry. So this is a simple idea. Okay. Next, conductors and insulators. That is quite simple only. Cherry, we'll move on to the next module. Next one, then Coulomb's law. Again, we will see what is the Coulomb's law.
Deriving Coulomb's law. In an atom, the electrons revolve around the nucleus. This is because of the electrostatic force of attraction between the negatively charged electrons and the positively charged nucleus. This is similar to the motion of the planets around the Sun due to the gravitational force of attraction between them. However, it is important to note that the gravitational force between two masses is always attractive, while the electrostatic force between two charges is attractive for unlike charges and repulsive for like charges. But is there any law that correctly describes the force between two charges, somewhat similar to the universal law of gravitation that describes the force between two masses? Coulomb's law. It accurately describes the variation in electrostatic force between two charges with distance. This law was proposed by Charles Augustin de Coulomb in 1785. To deduce this law, Coulomb performed an experiment using a torsion balance. In a torsion balance, a non-conducting horizontal bar is suspended by a torsion thread. The thread is attached to a torsion head at the top. The torsion head has a scale that indicates the force on the torsion thread. A metal sphere and a flat metal disc are attached on either sides of the suspended horizontal bar. Another metal sphere is suspended by a fixed, non-conducting rod and touches the metal sphere suspended by the horizontal bar. A circular scale on the surrounding glass wall indicates the distance between the metal spheres. Coulomb charged the metal spheres with equal and similar charges by touching them both with another charged sphere. Consequently, the spheres repelled each other and the torsion thread was twisted. Coulomb measured the distance between the spheres and the magnitude of the repulsive force from the torsion scale. He then reset the torsion thread to bring the suspended metal sphere closer to the fixed metal sphere and again measured the force and the distance between the spheres. After taking 3 such readings, Coulomb reduced the charge on the fixed sphere to half by touching it with another similar sphere. This way, he measured the forces between the spheres for different pairs of charges at different distances. Let us now analyze Coulomb's findings from the experiment. Look at these 2 charged spheres of diameter d1 and d2, having charges q1, 2 respectively, and separated by a distance r. Now, since the diameter of the spheres are much smaller than the linear distance r between them, it is appropriate to consider the spheres as point charges. From the experiment, Coulomb found that the force F acting between the point charges is inversely proportional to r square. If we actually plot the force versus distance curve on a graph paper, we will get a hyperbolic curve. Observe that if we reduce the distance by 2-fold, the force increases by 4-fold. Or, if we increase the distance by 3-fold, the force reduces by 9-fold. Coulomb also found that F is directly proportional to the product of Q1 and Q2. So, combining these 2 relations, F is proportional to Q1 Q2 upon r square. From his findings, Coulomb proposed a law, which is called Coulomb's law. It states that the electrostatic force between 2 point charges is inversely proportional to the square of the distance between the 2 charges, is directly proportional to the product of the magnitude of the 2 charges, and acts along the line joining the 2 charges. We can write the relation as F is equal to the product of some constant, say K, into Q1 Q2 upon R square. This equation is known as Coulomb's law. Here K is the proportionality constant, known as electrostatic force constant, sometimes also called Coulomb's constant.
See, if you replace Q1 and Q2 with M1 and M2 and K with G, Coulomb's law will look similar to the universal law of gravitation. Both these laws follow the inverse square rule.
In the SI system, the value of K in vacuum is 9 into 10 to the power of 9. Later it was found that the value of K is equal to 1 by 4 pi epsilon 0, where epsilon 0 is the permittivity of free space. So, in vacuum, the expression for Coulomb's law is 1 by 4 pi epsilon 0 into Q1 Q2 by R square. For 2 unit charges at unit distance in vacuum, the Coulomb's force Fq between the charges is 9 into 10 to the power of 9 Newton. On the other hand, the gravitational force for 2 unit masses at unit distance is 6.67 into 10 to the power of minus 11 Newton only. These values show that although Coulomb's law is very similar to the universal law of gravitation, Coulomb's force is stronger than the gravitational force. Let's now recapitulate what you have just learnt in this animation.
Yeah, is it clear, students? Coulomb's law வந்து entirely we have seen. So ஏற்கனவே நம்ம பார்த்துட்டோம். Okay, so this is the Coulomb's law concept. So they did a very nice comparison between Coulomb's law and the universal law of gravitation. So which one is much stronger? Obviously, the Coulomb's law is much greater than the gravitational force. ஏன்னா power பார்த்தீங்கன்னா it's a positive power. 10 to the power 9. 9 times 10 to the power 9 is greater, no? Than 6.67 into 10 to the power minus 11. So therefore, the magnitude of Coulomb's force is greater than the magnitude of gravitational force. Okay, and what are the factors on which Coulomb's force depends on? Yes, யாராவது சொல்ல முடியுமா? What are the important factors? Yeah, it depends on the distance between the two charges. Very good. And how is it varying with respect to distance? You know that the force
is directly proportional to 1 by R square.
Yeah, it is inversely proportional to the square of distance. Direct சொல்ல மாட்டோம், inversely 1 by R square and சொல்றோம் இல்லையா? So we use the term inverse. So as the distance reduces, what happens to the forces between two charges? Will it increase or decrease? Yes, it will increase. Yes, ஏன்னா அது inversely proportional அப்படிங்கிறதுனால. But it is directly proportional to the product of the charges. Okay, that is the difference. So Coulomb's law ஓட formula வந்து F is equal to K Q1 Q2 upon R square, where K is nothing but your electrostatic force constant or Coulomb's constant அப்படின்னு சொல்லலாம். The value of K is 9 into 10 power 9. What is the unit of K? Value வந்து 9 into 10 power 9. Unit வந்து what would be the unit?
Newton meter square per Coulomb square.
Yes, Newton meter square by Coulomb square. Very good. So that's how you find out the unit. Sure. Now we are moving on to the next module.
என்னென்ன பண்ணணுமோ அதெல்லாம் பண்ணிடுங்க. அந்த டே ஆஃப் கிவிங் த மெஷின், நாட் த மணி. மணி வந்து நான் முன்னாடியே கொடுத்துறேன். நீங்க மெஷின் வாங்கி உங்க வீட்லயே இங்க வச்சிட்டு அந்த
இங்க ஃபோர்ஸ் எல்லாம் கொடுத்திருக்காங்க. They have given you the force as 10. So appropriately you will have to calculate what is the forces between two positive charges when they are separated by distance of 4 centimeters. What happens to the force? In the value of force would be correct? 2.5, 10, 20.
அதனால தான் நான் அந்த ஆடியோ போடுங்க, அந்த வீடியோ எடுங்க எல்லாம் சொல்றதுக்கு காரணமே இதெல்லாம் தான். அவங்கள வந்து அந்த டோனர்ஸ்
So what would be the value?
பண்ணாதான் நமக்கு மேலும் மேலும் உதவி பண்றதுக்கு நிறைய பேர் இருக்காங்க. ஆனா நம்ம கிரவுண்ட் ஒர்க்ல சரியா பண்ணாதவங்க தான் நிறைய பேர். யாருமே சரியா பண்றது இல்ல, ஓபனா சொல்றேன்.
K is anyway constant.
ஆமா, நான் பார்த்துட்டேன். இது 4 வருஷமா நான் ட்ரைங் டு
F is equal to K Q1 Q2 by R square, isn't it?
அது சரியா பண்றது இல்ல. அதையே
So use that concept and find out.
நீங்க அவுட் சோர்ஸ் பண்ணாங்க. நீங்களும் கஷ்டப்பட்டு உட்கார்ந்து அந்த
So for the two charges separated by distance of 4 centimeters, what would be the force? Would the force increase or decrease? force will decrease, isn't it? Because you're going apart. It's inversely proportional to the square of the distance between them. So in the 4 centimeter case, it is going to decrease. In 1 centimeter case, it is going to increase. Okay. So that's the idea. That is basically the idea. We need to know that only. So now we move on to the next module.
பேட்டு பால் எல்லாம் வாங்கி கொடுத்து அவர் T20 செலக்ட் ஆயிட்டார். T20 பிளைண்ட் கிரிக்கெட் T20 செலக்ட் ஆயிட்டார். அது நாங்க வாங்கி கொடுத்தனால செலக்ட் ஆனாலும் அவரோட திறமையான ஆயிட்டார். அது நல்ல நியூஸ் வந்தா குட்.
Now we are going to see the next one, the electrostatic force.
அவர் என்ன எதிர்பார்ப்பார்னா உண்மையாவே போய் சேர்ந்துதான் அந்த தினகருக்கு. ஒண்ணே
Electrostatic force. Force is the external agent that acts on an object and causes it to move. Let's place a baseball on a table. At this point, the ball is stationary, but if we push it just a little bit, it will roll forward slowly. If we push the ball harder, we are applying greater force. More force will make the ball roll much further. We can say that force can set a stationary object into motion. Let's consider another situation. A wooden box just sitting on the floor is stationary. But if we tie a rope to the box and pull it, the box can be moved from one place to another. In these situations, the force at work is referred to as contact force because we are physically in contact with the object. Non-contact forces require no physical contact to relocate an object. Electrostatic force and magnetic force are non-contact forces. In this session, let's concentrate only on electrostatic forces. Electrostatic force is the phenomenon of electricity at rest, meaning stationary electrical charges. If you rub a balloon with a silk cloth and then hold the balloon, more pieces of paper, the paper will appear to be drawn towards the ball and then stick to it. All objects, including our balloon, have stationary electrical charges. But what is happening when we rub the balloon with the silk? As we rub the balloon, electrons from the cloth will move over to the balloon, giving it a negative charge. The paper pieces will also have stationary electrical charges. When we bring the charged balloon near the paper pieces, the electrons will be repelled, causing them to move away from the balloon. This will leave only positive charges in the area near the balloon. Because opposite forces attract, the paper will be attracted to the balloon. Let's do another experiment. We'll rub the face of two balloons with our silk cloth and then bring the faces so they are opposite each other. This time, we'll see the two balloons repel each other. Since each balloon has a negative charge from the silk cloth, they will Summary.
Okay, so in the module 11, what did we see? We looked at the interaction of charges. So basically, like charges would attract and unlike charges would repel. So nature of charges when we have learned. So how the nature of charges would interact with respect to each other. So we learned about the electrostatic forces of attraction and repulsion existing between the balloons. So render balloons nama kondu vandappo. So when they had the same type of charges, that is negative charge, so they repelled each other. When they have opposite charges, they are going to attract each other. So that's the basic idea we are trying to understand. So moving on to the next one. This is again a simple activity only. So we will move on to the next module. Now we are coming to the concept of electric field. So we'll try to understand this. So I all gave you we have done problems still here in the last class. So now we are just seeing the concepts again.
Electric field. An electric field is the region surrounding electrically charged particles. Let's take a look at how these charged particles can cause electric fields. To begin, we'll rub a glass rod with a silk cloth. This rubbing will remove some electrons from the rod, leaving it with a positive charge. Now we'll bring the rod near to a pith ball. When the positively charged rod is placed within the vicinity of the ball, the electrons in the ball will move slightly towards the rod, while the protons will move slightly away from it. Because the electrons are closer to the rod than the protons, the ball will swing towards the rod. The glass rod is said to have an electric field. In a similar way, a Van de Graaff generator, when charged, will attract a metal ball brought near it. An electric field will be created around the generator, influencing any charged or uncharged body entering the field. Here, the generator is the source of charge, while the metal ball is referred to as the test charge Q. The strength of an electric field is a vector quantity, having both magnitude and direction. When placed within the electric field, the test charge will experience an electric force F. The strength of the field can be derived using the equation E is equal to F by Q.
Yeah. Try to understand. So we'll just stop here and try to learn what's happening here. So electric field அப்படிங்கிறது என்ன அப்படின்னு பாத்தீங்கன்னா, it is a three-dimensional region. It's a 3D region surrounding the charge where the influence of the charge is being felt. So field அப்படின்னு சொன்னாலுமே it is nothing but a space, a three-dimensional space where the influence is felt. இப்போ magnetic field அப்படின்னு நம்ம சொன்னோம் அப்படின்னா, what is magnetic field? It is the region surrounding the magnet where the influence of the magnet is felt. Influence of the magnet, அது attractive இருக்கலாம், it can be attraction or it can be repulsion. So like poles of the magnet would repel, unlike poles is going to attract. நம்ம வந்து we have learned that. தெரிஞ்சதுதான். Same way, when you talk about electric field, it is the charge. It is basically the space surrounding the electric charges where the influence of the electric charges are being felt. So that is the region. That is the electric field region. So as the distance, you can see here, electric field is defined as the force that is acting between the two charges. Okay, the force existing per unit charge is basically called electric field. The force experienced by a unit charge, okay, placed in a region in space is defined as the electric field of that corresponding charge. So that is what we try to understand. Okay, so continuing.
Where E is the electric field strength, F is the force, and Q is the charge. An electric field can be diagrammatically represented with electric field lines indicating both the direction and strength of the field. Electric field lines begin at a positive charge and radiate outward. Conversely, they are directed radially inward toward a negative charge. The line will be denser around a higher charge and less dense around a weaker charge.
So electric field, when you're trying to visualize for positively charged species or positive charges, the electric lines of forces are radiated outward. They are present outward in all directions, like a sphere. Okay. Negative charges, they are radiated inward. So that is the direction of electric lines of forces between positive and negative charges. For positive charges, they are radially outward, wherein for negative charges, they are going to be radially inward. So that's how you visualize them, the electric field for both positive and negative charge. Okay, so we'll continue.
When two similar charges approach, the lines will diverge. And when two opposite charges approach, the lines will converge towards the negative charge. In the case of an electric dipole, which consists of two separated point charges having the same magnitude but opposite charges, the electric field lines will be curved. they will extend from the positive to the negative charge. At any
So inge வந்து we try to understand the electric lines of forces with respect to both positive and negative charges. So when we brought two two like charges would repel each other, and therefore the electric lines of forces, they diverged each other. They never touched each other. They never intersected each other, isn't it? But when you brought two unlike charges, or positive or negative charge, when you try to bring it, you can see the electric lines of forces are away from the positive charge, but they converge at the negative charge. It is convergent. So the electrostatic, or you can say the electric lines of forces between positive and negative charges are convergent, wherein between two positive or two negative charges would be divergent in nature. So that's what we understand by convergent and divergent. Saringla? So we are moving on. So that's all about the electric lines of forces.
At any point on the line, the field created by the dipole will be tangent to the line at that point. Summary. An electric field is the region surrounding electrically charged particles. The strength of the electric field can be derived from the equation E is F Q. Electric field lines depict the direction and strength of the electric field. Electric field lines radiate from a positive charge towards a negative charge.
Yeah, so that's all about this module. So let's go on. Let me reshare. I got locked out.
Electric field lines and electric flux.
So now we are seeing electric field lines, and what is meant by electric flux we'll be seeing.
We know that a charge produces an electric field around itself. But does the strength of the electric field vary with distance? This animation will throw more light on the electric field due to a positive charge. This translucent sphere portrays the electric field around a positive point charge. Here's a two-dimensional representation of this electric field. The electric field intensity at a point decreases inversely as the square of the distance of that point from the charge. This is indicated through the length of the arrows. Observe that the outward arrows get shorter as they move away from the positive charge. Now, let us connect the aligned multiple arrows by...
So why is the outward arrow very less in length? That is because, what is the reason? In inner arrows were, lengthy, they were more lengthy, but outer arrows were very short. What is the reason behind it? Yes? Anybody?
Sir, outer arrows are away from the charge.
Yeah, the outer arrows are away. Basically, it is in correspondence to the Coulomb's law, right? It's very similar to it. So as you go away from the charge, what happens to the strength of the charge? Electric field strength is going to decrease. That is why the outer arrows were relatively shorter than the inner arrows. Good. Okay.
By a single arrow. The resultant arrow is known as a field line. Now, the electric field strength is portrayed by the density of the field lines. Electric field lines are closer near the charge, which means the electric field is stronger there. Likewise, as we move away from the charge, the electric field lines are more apart, indicating that the electric field is weaker in that region. You may draw more number of lines, but the electric field intensity is dependent only on the relative density of field lines. Simply speaking, the electric field at a point is relatively stronger if the field lines are more crowded near an area under consideration. The electric field lines are more crowded near a charge compared to a region away from the charge, indicating that the electric field intensity decreases as we move away from the charge.
So electric field strength is decreasing as you move away, but if you're closer, the electric field strength is increasing. Why? Because number of electric lines of forces passing per unit area is greater as you are closer. Number closer, if you are very close to the charge, the positive charge which is depicted here, the electric field lines are greater there. That's the reason the electric field strength is also greater. But what happens as you move away? You can see that the number of electric lines of forces passing that particular area would be lesser. And hence you say the electric field strength is also lesser. Okay, so that's the idea. Okay, so we'll move on.
Let's now try to represent mathematically the relationship between the density of field lines and the electric field intensity. Consider a positive charge placed at point O. Consider 2 points Q1 and Q2 that are located at distances R1 and R2 respectively from the point O. Let's take the cross-sectional area of the plane that is perpendicular to the field lines at the point Q1. Let's represent this area element by A1. A1 subtends a solid angle delta omega at point O. Similarly, we take another area element A2 at point Q2, subtending the same solid angle delta omega at point O. Note that the number of field lines, say N, remains identical within the solid angle cone. The area of element A1 is given by the following equation. Similarly, the area of element A2 is given by this equation. Since the number of field lines passing through areas A1 and A2 are both equal to N, we may wrongly interpret that electric fields are equal at A1 and A2. To circumvent this problem, we compute the electric field lines passing per unit area element at Q1 and Q2 as follows. Note that the number of field lines N and the solid angle delta omega are the same in both expressions. Thus, we can clearly see that the electric field strength varies inversely with the square of the distance from the charge.
So the distance only is taken as a main criteria to identify the electric field strength, not the angle nor the number of electric lines of forces passing per unit area. So it is the distance from which you are trying to study the electric field strength. So at area A1 you can see the number of the crowding of the electric lines of forces are greater. It is more crowded there. That is the reason the electric field strength is much stronger at area A1 than area A2. Okay, that is point Q1 has a greater electric field strength compared to point Q2. The reason is the number of electric lines of forces passing per unit area in A1 is greater. That's point number one. Second, the distance is also very less. Okay, R1 is less, but R2 was greater. So therefore, you try to understand the relation between the electric field density, the electric field intensity, and the relative distance between those 2 points. Sharingla? So that's the idea. Okay, is this clear? The electric field intensity concept?
Yes, sir.
Yeah, okay.
However, in real life, it is not possible to count the number of field lines passing per unit area. Moreover, the cross-sectional area element may be at an angle to the field lines or even parallel to the field lines. How then do we measure the strength of the electric field? We can find a solution to this impasse by defining two new quantities, the area element vector and the electric flux. We associate a vector to a surface area which we call the area vector. The magnitude of this vector is the area of the surface and the direction of the vector is the normal to the surface.
So when I say normal to the surface, normal na என்னது? It is basically a perpendicular that is drawn. Yes. நீங்க வந்து லைட் சாப்டர்ல படிச்சிருப்பீங்க grade 9 or grade 10. So you will draw normal at the point of incidence, isn't it? So normal is a line, an imaginary line that is perpendicular to the surface, okay, in contact. So here when you take a surface here, this surface looks like a very thin flat cuboid. Okay, we are taking a very small thin slice of the cuboid. So the area vector for this flat area would basically be normal to that area, normal to the surface. So normal is basically a line which makes an angle of 90 degrees and it is radially outward. So that is the area vector. So moving on.
But a plane surface will have normals in two different directions. So to avoid confusion, we always consider the direction of the area vector for a closed surface to be along the outward normal.
Yeah, so here we always deal with normal that is radially outward. It is present outward from the surface, not inwards. Okay, so generally we take them as outwards.
If the surface is curved, we divide the surface into small planar elements and we associate a vector to each of this area element, which we call the area element vector. As a convention, the area element vector points outward. We can now define the electric flux phi as the dot product of the electric field and the area element vector delta S.
So electric flux is also a quantity which defines, the dot product of electric field intensity and the area element. Area element, the area vector which was normally outward. Just now we saw. Yeah, so the dot product of two vectors. Now who can tell me when you resolve the dot product, what do you get? For example, vector A dot vector B. So what is the formula for a dot product of two vectors?
AB cos theta, sir.
Very good. AB cos theta. Perfect. Whenever you go for a dot product, AB cos theta. The angle between these two vectors, if it is theta, you express them as AB cos theta. The same thing if I ask you, what is the cross product of two vectors? Vector A cross vector B. What would be the formula?
Mod A into mod B sin theta in caps, sir.
Yes, sin theta. So you can see there the trigonometric ratio would change. It would be sine. For dot, it is cosine. So under a variation now. So that is what you need to keep in mind. And we use the modulus also. That's quite important. So taking the modulus of a vector also is very, very important. So I'll give you a simple question and with that we'll wind up. I know I'm taking more time. So today I hope it's still 8:30. I'll just confirm it. Sir, 8:30 varikungla? We have it till 9 today?
You can carry on.
You can carry on till 9? Oh, okay.
Yeah.
Okay, fine.
பசங்களா ஃபர்ஸ்ட் சொல்லுங்க.
Yeah, so just let me know. So இப்போ வந்து ஒரு simple question தான் நான் கொடுக்க போறேன். So to ensure that the vector concept is clear. So அதுக்காக I'm just giving you a simple question. So tell me, I will just write it here, okay? நான் இங்க வந்து எழுதுறேன், annotate பண்றேன். I'm giving you a vector. Tell me what is the magnitude of this vector that I'm writing on the screen. Okay, I'm just representing a vector here. So tell me the magnitude of this vector. So I'm representing a vector 5i cap plus 3j cap minus k cap. What would be the magnitude of this vector? Yes?
Root 35.
Under root? 30.
35.
35. Okay. How did you get the answer? Anybody? How you're getting it?
Root of 5 square plus 3 square plus 1 square.
Correct. 5 square plus 3 square plus 1 square. So we are only taking basically the coefficients of all the unit normal vectors. I oda coefficient pathina 5, adanala 5 square. J coefficient பாத்தீங்கன்னா 3, K coefficient பாத்தீங்கன்னா -1, but -1 the whole square would give you 1 only. So 5 5s are 25 plus 9 plus 1. So accordingly you will get the answer. Is it clear? So that's how you find out the magnitude. Very good. So that's very important to know. So inge the electric flux is given by the area element. So we can express this as the dot product of electric field intensity, the electric field vector, and the area vector, which is unit normal to the surface. And theta is the angle between the electric field and the area vector. Okay, so that's the idea. So we'll move on.
This could be further written as follows, where theta is the angle between the electric field and the area element. Now, let's recapitulate what you have just learned in this animation.
Just a summary of what we learned. So now moving on to the next part. Okay, this is the same electric field lines which we have seen. So we'll see some questions based on this and then we'll move on. Cherry, here's the first question. So try out these questions. First question kaat raha hai. The electric field lines are shown for charges Q1 and Q2. Which of these statements are correct?
Sir, Q1 is positive charge, Q2 is negative charge, sir.
Yeah, so it would be
Option
option C. Yes, that is correct. Next question. So based on the topic understanding, we will see. Now net charge, you have Q. So near the charge Q. Okay, this question is incomplete. We'll move on. Sorry. Ipo another question. If two equal charges in air are 3 centimeters apart, exerting a force of 40 newtons on each other, what is the magnitude of each charge? So apply the Coulomb's concept and tell me the answer. So take your, if you have your book, you can work it out and then give me the answer. Yes, anybody got the answer for this? Yes, what is the answer? Anybody? So you solve panum theriyungla illa you want me to show it how it needs to be done?
0.2 microcoulomb.
0.2 microcoulomb. Okay, let's check. No, that's wrong. Okay, so I'll tell you how it needs to be done. Let me share the blackboard so that I'll work it out there. Yeah, just hang on. Let me open the blackboard. It is getting loaded. Yes, is my blackboard visible now?
Yes, sir.
Yes, sir.
Yeah. So what was given in the question? First step, you write down what is given in the question. Okay. So question வந்து என்னென்ன values கொடுத்திருந்தாங்க? They have given the force.
Force 14 Newton, sir.
40 Newton. And the distance எவ்வளவு கொடுத்திருந்தாங்க?
3 meter.
3 centimeters
3 centimeter தானே கொடுத்திருந்தாங்க, மீட்டர் இல்ல.
apart from
Each other. So 3 centimeter na, it is 3 into 10 to the power minus 2 meters in எழுதிக்கலாமா? Isn't it? Converting centimeters to meters. Isn't it? Yeah. This they have asked and they have told that charges are equal. Charges are equal na என்னது? Q1 is equal to Q2. அதை வந்து Q ன்னு எடுத்துக்கலாம். Okay. Now from Coulomb's law, what do you know from Coulomb's law?
F is equal to Q1 Q2 by R square.
Correct. So we are using that concept. So F equals K Q1 Q2 by R square. It's the formula. So you know that Q1 and Q2 are same. So in the வந்து நம்ம எப்படி எழுதிக்கலாம்? So we can write F is equal to K times Q square by R square எழுதிக்கலாம். Isn't it? Can we write it
Yes,
like this?
sir.
Yes. So what do we need here? We want only Q. So keep Q on one side and shift all other terms to the other side. What do you get? You get
F into R square by K.
Yeah. F R square by K is what you get. Under root. Yeah, now you wanted only Q, not Q square. So substitute the values. F is 40 newtons. So 40 into R square. R square na 3 into 10 power minus 2 the whole square. 3 square vandu is 9. Yeah. 10 power minus 2 the whole square is
10 power minus 4.
Yes. Minus 4 divided by K oda value vandu 9 into 10 to the power 9 then. That's the value of K. Correct? So I can cancel out 9 cancel பண்ணிரலாம் இல்லையா? So we can cancel out and now simplify the values. 10 power 9 going up will become 10 power minus 9. 10 power minus 9, 10 power minus 4 will be 10 power
5.
Minus 13.
Minus
Correct.
13, sir.
10 power minus 13. So you already have 40 inside. 40 is having one more 10 power 1. So it can be written as 4 into 10 to the power minus 10 power.
Minus 14.
Is it minus 14?
Minus
Minus 12, sir.
Okay, minus 12. So overall pathina it will be minus 12. சரியா? Because the 10 also you consider. If you extract it outside the root, 2 will come outside, the 4 will come outside as 2 and 10 power minus 12 can be written out of the root as 10 power minus 6 then minus 6 the whole square then 12. So it will come out. So the answer is 2 into 10 power minus 6. What is 10 power minus 6? Micro. So answer is 2 micro coulomb. That is what you said. Let me check. No. So what you said was basically 0.2 microcoulomb. So the answer is 2 microcoulomb. Option B is correct. Is it clear? Yeah,
Yes,
so
sir.
this is the answer. Sharia, we'll go to the next one. Adutha question pola. Yes, this is the next question. Yeah. If the inward and outward electric flux of a closed surface are 8 into 10 power 3 coulombs and 4 into 10 power 3 respectively, the net charge inside the closed surface is. So what is the total charge? அப்படின்னு கேக்குறாங்க. So what is the
4 into 10 power 3.
huh?
4 into 10 power 3. sir.
4 into 10 power 3. No, it's not 4 into 10 power 3. They have told
Option
inward
B.
and outward then. So what would be the answer?
Option D.
Option B. No. Option B or D? No.
Sir, C, sir.
Okay, so how are we doing this? We are talking about
Sir,
the-
outward minus inward up and down, sir.
Yeah, so it is out inward and outward கொடுத்திருக்காங்க for a closed surface. So obviously you know what for outward, how it is. The radial forces are outward na, it is positive charges. Inward na, obviously it is going to be the negative charge then, isn't it? So அதுக்கு தகுந்தாப்புல நம்ம சைன் போட்டுக்கணும். புரிஞ்சுதுங்களா? இன்வர்ட்னா என்னது? It is moving inwards. And what is the nature of charge? நெகட்டிவா இருக்கணும். So what would it be? It would be minus 8 times 10 power 3. So outward means it is plus 4 into 10 power 3. So அதுக்கப்புறம் net charge na, you have to take the and consider add both of them. So when you add minus 8 and plus 4, நமக்கு என்ன கிடைக்கும்? Minus 4 தானே we'll get, isn't it? So it is minus 4 times 10 to the power 3. Now unit here would be in terms of epsilon naught. ஏன் epsilon naught போடுறோம்? ஏன்னா you are expressing in terms of permittivity of free space. சரிங்களா? So that's all. So this is all about the relationship. இங்க வந்து we are using that relationship. சரி, moving on to the next one. Okay, this one. Are you able to see the question? I think it's very small. Is it visible? Yes. Okay. If you want, I'll zoom it. I think now you can see. This is a question. In the question, you just write down the given values so that you can solve them. அதுக்கப்புறம் நான் options காமிக்கிறேன். So first, try to write down the given values. அதுக்கப்புறம் we'll solve it. So picture draw பண்ணிக்கோங்க so that it will be, you will have the question with you. ஓகேங்களா? எழுதிட்டீங்களா all the given values? Yeah, I'll again explain the question also for those who didn't understand. So இங்க வந்து ஒரு you are placing basically if 1 minus 1 microcoulomb, microna 10 power minus 6 ஏற்கனவே நான் சொன்னதுதான், is placed at a point of 2,4. At the coordinate point of 2,4 அவங்க பேஸ் பண்ணிருக்காங்க. 2,4 வந்து எதை குறிக்குது? It is showing you the direction in the xy plane. So xy plane ல வந்து the coordinates they have kept in that coordinate of 2,4 at a distance of 2 meters from x-axis and 4 meters from y-axis. அதனால 2,4. Then the intensity of electric field at the origin due to this charge. இங்க வந்து electric field intensity கொடுத்துட்டாங்க. So electric field intensity is 4.5 into 10 power 2 newtons per coulomb. In the direction making an angle of tan inverse of 2. So it is making an angle of tan inverse of 2 with which one? Is it going to make the angle tan inverse with x coordinate or y coordinate is the question. So நமக்கு எல்லாருக்கும் தெரியும் what is tan theta?
Opposite side by adjacent.
Correct. So opposite upon adjacent. So அங்க ஒரு line draw பண்ணிக்கோங்க between O and P and try to find out the angle of tan. So tan inverse 2 அப்படினா, so which corresponding value they are talking about. So you have 4 options. Is it negative y, positive x, positive y and negative x? So and the option will be correct for this question. So which one would be the answer? Anybody? Positive?
X.
Positive x. Okay. Very good. It's positive x. Can you explain how you got the answer? Good. It's correct. Positive x is correct. எப்படி வந்தது positive x? ஏன்னா your tan inverse of 2 அப்படிங்கும்போது what is the component of 2? Can you see the 2 is lying on the x-axis? இல்லையா? So obviously it is going to be in the positive x direction. Okay. Fine. Okay. So இது வந்து we will learn after we learn Gauss theorem. So then we can do these questions. Yeah, this question you can try. Electric field lines of an electric field is given by x square plus y square is equal to 1 on the xy plane. If a unit positive charge is placed as x is equal to 0 and y equal to 0, x equal to 1 and y equal to 0, then the particle will be. So they are placing it on the x-axis itself at a distance of 1 meters. So will it move, not move, or move in a straight line, or move in a circular path, or none of the above? இங்க வந்து நம்ம ஈக்குவேஷன் தான் யூஸ் ரிலை பண்ணணும். So what does x square plus y square equal to 1 represent? What is the path?
Circle.
Very good. It is a unit circle, இல்லையா? This represents a unit circle. So what will be the trajectory?
Move on circular.
On the circular path? Yeah. Is it clear? So based on the equation, we are coming to a conclusion. சரிங்களா? So quite easy only. Okay. So moving on. The number of electric lines of forces that radiates from a charge of 1 coulomb.
Option A.
Option A. 9 into 10 power 9. Okay. No, it's not option A.
Infinity.
Can you say that they are just
Sir, infinity, sir.
infinity? No, it's not infinity also. It is 1.13 into 10 power 11. So how are we getting this number? Anybody? How are we obtaining this number of electric lines of force that radiates from a charge of 1 coulomb? So what is the formula? Yes, which formula do we rely on? Easy only this is.
Is equal to F by Q naught.
E is equal to F upon Q naught. Okay, that is relation between electric field intensity, force upon charge. Seri. So here you have only the charge. We don't have the force, nor the electric field. So we are going with the concept of the electric flux, which we learned, which gave us a relation between number of electric lines of forces.
E vector dot.
So n upon r square, you got the relationship, right? So the number of electric lines of force radiating outward. So when they're radiating outward, so the nature of charge is going to be positive. Okay. So we are using the number of charge enclosed by the surface divided by epsilon naught. Inga vandu nama Gauss theorem use pandrom. Still we have not gone until Gauss theorem. That's the reason you couldn't get this. So answer vandu Q divided by epsilon naught. And the concept da use pandrom. Electric flux is Q by epsilon naught concept. Epsilon naught value namakku ungalku theriyum illaya 8.85 into 10 power minus 12. So நம்ம அதோட டிவைட் பண்ணும்போது so Q வந்து இங்க 1 coulomb. So 1 by 8.85 into 10 power minus 12 will give you 1.13 into 10 power 11. சரிங்களா? அதனால தான் ஆன்சர் வந்து C இங்க. So அது வந்து இங்க வந்து சில क्वेश्चंस எல்லாம் ஹையர் லெவல் கொடுத்திருக்காங்க. அது வந்து நம்ம இன்னும் கவர் பண்ணல Gauss எல்லாம். Once we do the Gauss theorem, this will be easy. சரி. So with that, so we'll come to an end. So we'll wind up. I'll not take most of your time. சரிங்களா? So learn these concepts. I'll send you the notes. I'll upload it on Google Classroom. Okay. So I was not having a PDF maker. So now I have downloaded one. So உங்களுக்கு எல்லா நோட்ஸுமே I'll upload it there. சரிங்களா? So you can get access through the Google Classroom.
என்ன மனிஷ் இதெல்லாம் புக்ஸா?
என்னங்க
உங்க ஷெல்ஃப் மாதிரி காமிக்கிறீங்க, அதெல்லாம் புக்ஸான்னு கேட்டேன்.
புக்ஸ் இல்ல அங்கிள், இங்க வந்து அது வந்து இஸ் ஜஸ்ட் a screen saver.
ஓகே. இல்ல நீ நிறைய புக்ஸ் வச்சிருப்பியே, நான் பார்த்திருக்கேனே.
இருக்கு, புக் ஷெல்ஃப் இருக்கு. அது
ஆமா, நான் உங்க வீட்ல உங்க பாட்டி வீட்லயே இடம் இல்லாம இருக்குமே, புக்ஸ் வச்சிருப்பியே.
அந்த புக்ஸ் வந்து இஸ் தாத்தாவோட புக்ஸ் இருக்கும்.
ஓ, அது
ஆமா.
சரி.
ஆமா.
ஓகே.
So he is having a habit.
Okay. All the best. Thank you.
Okay, uncle. Yeah.